Welcome, geometry students, to the homework help video, page 166, numbers 1 through 18, 23 through 26, 31 through 39, and 40 through 47. Let's go ahead and get started with numbers 1 through 6. Here we go. Match the triangle with its name. So, here we go. Let's see what we've got here. Number 1, a triangle that has a side of 2, 3, and 4. Well, that means we have a triangle in which all three sides are not congruent, and that is called a scalene triangle. So number 1 should be scalene, letter B, and we actually got one right, so a miracle still happened. Number 2, angle measures 60, 60, 60. Well, we've learned that when all three angles in a triangle are congruent, we call this an equiangular triangle. That should be letter D. Letter D. All right, 2 for 2. Number 3, we have a triangle that has side measurements of 3, 2, and 3. So we have two sides that are congruent. Two sides that are congruent. Well, whenever a triangle has two sides that are congruent, we call that an isosceles triangle, and that would be letter E, isosceles triangle. All right. Number 4, angle measures of 30, 60, and 90. Now, we're dealing with angle measurements, of course, so we have a choice of acute triangle, obtuse triangle, equiangular triangle, or right triangle. Well, if one angle is 90 degrees, we call that a right triangle, which would be letter F, right triangle. Number 5, we have three sides that are congruent. A triangle that has a length of 4, 4, and 4. We call that an equilateral triangle, letter A. And then lastly, we have a triangle that measures 20, 45, and 15. Degrees. Notice one of the angles is larger than 90, and whenever you have a triangle in which one of the angles is larger than 90, we call that an obtuse triangle, which would be letter C, obtuse. Okay, moving on. We're going to use this triangle over here for these problems, and you know what? I looked ahead and I realized we need to look at this triangle as a whole, but we also need to split it up because they're going to ask us questions about each individual triangle. So I'm going to try to copy these triangles if at all possible. And really, with my drawing skills, anything is possible, and that's definitely not a good thing. Alright, there we go, and there we go. And let's quickly label these, then we'll continue on. QPR, so QPR, and then SPR. And here we go. PQ is the blank of the right triangle PQR. Well, here's the right triangle PQR right there. PQ is the what? Well, let's see, where's PQ? Let's go ahead and put some right angles in here. There's a right angle, there's a right angle. Well, PQ, remember the right angle always points to the hypotenuse, so PQ would be the hypotenuse. All right, moving on to number 8. In triangle PQR, which of course is this triangle right here, PQ is the side opposite vertex what? Well, here's PQ right here. Now, what vertex is straight across from that side? Well, it's vertex R. Remember, Q is a vertex, P is a vertex, and R is also a vertex. Okay, so R is the vertex directly across from side PQ. All right, so with that in mind, that would be R. Okay, moving on to number 9. QS is the blank of the isosceles triangle PQS. Now here's the isosceles triangle PQS right up here. That's the whole triangle together, and we know it's isosceles because of this congruent mark here and this congruent mark here. Okay, now what they're asking us is what is QS called? Well, we learned that in an isosceles triangle, the two congruent sides are called legs, and the non-congruent side is called a base. So side QS is called the base. Okay, the base. All right, number 10, angle QPS is blank. Now, let's see here. And if you'll look in your book, they've given you choices acute, right, or obtuse. And again, that's going to be angle QPS. So here's angle QPS right here, this angle here. And notice this entire angle is made up of two angles. One is 35 and one's 35. So the whole angle is 70. So if the whole angle is 70, which it is, then the angle is acute. It's not right. It's not 90 degrees, and it's not obtuse. It's not bigger than 90, so it would have to be acute. The legs of triangle PRS, so here's PRS right here, PRS. The legs of this triangle are what? Well, here's the right angle, and the right angle always points to the hypotenuse, so we know this side is the hypotenuse, so the legs would be this side here and this side here. So PR and RS would be the legs. Okay? All right. Moving on to numbers 12 through 14. Name 3 pairs of congruent angles. Well, students, here we go. Angle M has 1 slash and angle N, so angle M is congruent to angle N. Angle L has 2 slashes and angle O has 2 slashes, so angle L is congruent to angle O. Angle P has 3 slashes and angle Q has 3 slashes, so angle P is congruent to angle Q. Alright, so there we go. Hopefully we got that right. Looks like we did. Next, it says to name 3 pairs of congruent sides. So, LM has 1 mark, and NO has 1 mark. Alright, let's see. LP has 3 marks, and QO has 3 marks. MP has 2 marks, and NQ has 2 marks. So there we go. There's your 3 sets of congruent sides. Question number 14. If triangle LMP is isosceles, then why must triangle ONQ be isosceles also? Well, students, look. If the 3 angles in this triangle here are congruent to the 3 angles over here, and the 3 sides of this triangle here are congruent to the 3 sides over here, then that tells me these two triangles are what? Congruent. And if they're congruent and one of these is isosceles, then the other one has to be isosceles. So explain why it must be isosceles, because the 2 triangles are congruent. Okay, that's just the only way. They're congruent. All right. Moving on to 15 through 18, we do not have to draw these. I've mentioned that to you already. However, we are going to pretend we've drawn them, at least estimate that we've drawn them. And we're going to say that's 3, and that's 3. And what type of triangle would that be? Well, first of all, it would be equilateral because all 3 sides are congruent. And then secondly, it would also be acute because it's impossible to have an equilateral triangle and have any of these numbers, any of these angles be 90 or bigger. It's impossible. Okay, so this is an equilateral triangle, and it's also an acute triangle. What we're trying to do here, students, is we're trying to classify each triangle according to its sides and its angles both. Okay, all right, moving on to number 16. 2 sides measure 1.5 inches, and the angle between these is 120 degrees. So here's approximately 120 degrees, approximately. And we'll say this side over here is 1.5 inches, just pretend, and 1.5 inches. So what do we have? We have, based on the sides, we have an isosceles triangle because 2 sides are congruent, and based on the angles, we have an obtuse triangle because 1 angle is bigger than 90. So what we have for number 16 is an obtuse isosceles triangle. Obtuse isosceles triangle. Alright, number 17. The angles are 20, 70, and 90. So I'm going to go ahead and try to draw 20 degrees here. That's 45, so 20 is about like this. That'd be 20. And then I've got to draw 90 degrees, so 90. And that looks like that's about 70 right there. So we're going to call this 20, we're going to call this 90, and we're going to call this 70, okay? Now, first of all, if I ask you to classify this triangle based on angles, we would call this a right triangle. And if I ask you to, now be careful on this one, students, listen carefully. If I ask you to classify this triangle based on its sides, the lengths of the sides, You'll have to kind of read in between the lines a little bit and think this through, but there's no way these sides can be the same. For example, there's no way this side here, if this is 20 degrees, is going to be equal to this side over here across from the 70 degrees. And we should know this from middle school. I mean, the longest side in every right triangle is always the hypotenuse. In a right triangle, the hypotenuse is always the longest side. There's no side as long as the hypotenuse. So all three of these sides are different lengths. So we would call this a right scalene triangle. Okay? All right, and then number 18. Make sure I got this right. Okay, and then number 18. AB is 2 inches. So here's AB. Put an A here and a B here, and we'll call that 2 inches. Angle B is 60 degrees. I see that right here. So let's see, 60 would be about like that. I think that's about 60. And then BC is 2.75 inches, so it would be that much, then a little more, like that. Okay? And this is 60 degrees. All right, now let's take a look at this and think this through. First of all, we know that this side here is 2.75. So we know that this side here is not congruent to this side over here. And if you'll look at how I've drawn it pretty well to scale. There's no way that this side here is going to be the same length as this side here. And I know you're saying, well, Mr. Earhart, there's a chance that this side here could be the same length. Hold on one second, please. Could be the same length as this side down here. But really, if you took this and just swung it straight down, there's no way it could be as long as 2.75. Okay, there's no way. And so what we have here is an acute. The angles are going to be smaller than 90. Acute scalene triangle. Okay? Acute scalene triangle. I believe. I hope that's right. Yes, we're good. All right. Okay, moving on to numbers, I'm not sure, 23 through 26, I believe. Okay, students, in this section here, they want you to use the words always. If I can get my pen to work here. Always, sometimes, or never. So here we go. An isosceles triangle is always, sometimes, or never an equilateral triangle. Well, remember, the definition of an isosceles triangle is you have to have at least 2 congruent sides. You can have 3. So if I were to draw a triangle that had all congruent sides, that would be an equilateral triangle, but it would also be an isosceles, because an isosceles triangle has at least 2 congruent sides. It can have more. Okay, so is an isosceles triangle always an equilateral triangle? Well, no. Sometimes you'll have an isosceles triangle that looks like this: 5, 5, and 2. It's never, no, it's not never, sometimes. Sometimes an isosceles triangle will be an equilateral triangle in a situation like this, and sometimes it won't be in a situation like this right here. Okay? All right. Moving on to number 24. An equilateral triangle is an isosceles triangle. Well, I mean, we know that if you have an equilateral triangle like this, all 3 sides will be congruent. And if all 3 sides are congruent, then we have at least 2 sides that are congruent. So if we have at least 2 sides that are congruent, it'll be isosceles. So anytime we have an equilateral triangle, it will always be isosceles, always. Because if it's an equilateral triangle and all three sides are congruent, then we know at least two sides are congruent, okay? Okay, number 25. An obtuse triangle is an isosceles triangle. Now, let's think about this for a second. Can you draw an obtuse triangle that is not an isosceles triangle? Well, sure. Here's a really big angle there. There's a really big angle, bigger than 90. And obviously, all three sides are different lengths, okay? However, I can also draw a really big angle like this, in which this side here is the same length as this side over here. And so sometimes an obtuse triangle is an isosceles triangle, and sometimes it's not, okay? So the word would be sometimes, okay? All right, number 26. A right triangle is an acute triangle. Well, first of all, the definition of an acute triangle is all three angles are smaller than 90. So think about it. If you have a right triangle, then you know you have one angle for sure that's 90. So as soon as you have one angle that's 90, there's no way this triangle can be acute. So a right triangle will never be an acute triangle, okay? It's impossible. All right, let's continue on. This should be pretty simple here. We talked very well in your notes about congruent statements and lining up angles with angles and sides with sides that are congruent. So here we go. We have triangle ABC and triangle TUV. They're congruent. And so angle C right here would be congruent with angle V. So there we go. Angle C is congruent with angle V. Okay, angle P, which is right here, would be congruent to angle X. So angle P is congruent to angle X. All right. Let's see. Side LN, which is here, LN, would be congruent to side TV. All right. TV. And then segment DE, so here's DE, would be congruent to segment NO. Okay, so NO. And moving on, pretty simple. Okay, we're going to go quick through this. We're going to complete the table and write yes if it's possible, write no if it's not possible. And I'm not really too concerned if you illustrate your answers with pictures. But if it helps you, feel free to do that, okay? All right, here we go. Number 35. An acute triangle, can it be scalene? Yes. Can an acute triangle be isosceles? Well, here's a little angle and a little angle. There we go. I drew a triangle that has a small angle here, less than 90, a small angle here, a small angle here, and these two sides are congruent. So yes, it is definitely possible. How about an equilateral acute triangle? Definitely. Let me fix this real quick. Definitely that's possible. Excuse me. If I draw an equilateral triangle where all three sides are congruent, then all of these angles here will definitely be less than 90. So yes, it is definitely possible. Yes. Okay. Obtuse triangle, scalene. Yes, definitely. Draw a big angle here, so that's obtuse. Draw a little side here, and then a big side here. There's no way any of these three sides are congruent, but yet I have an obtuse triangle, so yes, definitely. Okay, how about an obtuse isosceles? Well, definitely. Draw a really big angle like this. That's bigger than 90. We'll call it 125. Just making that up. And I draw this side here, the same length as this side here, and then I connect those two sides. Okay, so definitely yes. And then is it possible to have an equilateral obtuse triangle? No, it is not. And you're going to learn this later, students, in a theorem. Let's go ahead and nail this down now while we're talking about it. An equilateral triangle will always have 60, 60, 60 for its angles. So, I mean, we're going to learn this officially later, but I'm going to go ahead and tell you now. If you have an equal angular triangle, then you have an equilateral triangle. And if you have an equilateral triangle, then you have an equiangular triangle also. So if it's an equilateral triangle, all of the angles must be 60. So no, it would be impossible to have an equilateral triangle that's also obtuse. Okay, that would not be possible. All right. Okay, moving on to a right triangle. Can you draw a right scalene triangle? Of course, yes. Draw a real long leg and then a small leg. So this side here is not congruent to this side here. And then draw your hypotenuse. And remember, the hypotenuse is always longer than either leg. So all three of these sides here are not congruent. So we have a right triangle in which all three sides are not congruent. So yes, it is possible to have a scalene right triangle. Now, is it possible to have an isosceles right triangle? Well, definitely. Draw this 2 inches and then draw this 2 inches there, and we have a right triangle, but yet this leg here and this leg here are congruent. This is also isosceles. So I have a right triangle and it's isosceles both. So yes, definitely. Now, can you draw a right equilateral? Well, no. Remember, we just talked about that. If you have an equilateral triangle, all three angles will always be 60. So one of them will not be 90. In fact, none of them will be 90. So it is impossible to have an equilateral triangle that also has a right angle. Okay, so no, that is not possible. Okay, all right, continuing on to numbers 36 through 39. Okay, numbers 36 through 39, the directions say to draw a triangle that has the indicated type of symmetry, if possible, and then identify the type of triangle. So here we go. Number 36, we want to draw a triangle that has exactly one line of symmetry. Now, you might be thinking equilateral triangle, but that would not work. That's not a very good equilateral triangle, but that would not work because this triangle here, if it's truly equilateral, will have more than one line of symmetry. I mean, there would be one here, and then also one here, and then also one here, if it's a true equilateral. We want a triangle that has exactly one line of symmetry. So I'm thinking an isosceles triangle like this. All right, there we go. Now that triangle there only has one line of symmetry. And even though I'm drawing challenge and I can't draw it, it'd be, wow, it's a really good line, but it'd be like that. Okay, so it'd be an isosceles triangle. Okay, now, no lines of symmetry? Well, just kind of use common sense. It would have to be a scalene triangle, a triangle that has no congruent sides. So like a side like this, and then one like this, and then let's grab this and swing it down just a little bit. Like this. Okay, that's what you call a deformed scalene triangle. But anyways, it's a scalene triangle, and there are no lines of symmetry at all. There's nowhere on this triangle that you could draw a line of symmetry. Okay, so a scalene triangle would be an example of a triangle that has no lines of symmetry. And I apologize, I skipped number 37. I did 36, 38. So now, just to thoroughly confuse you, we're going to go ahead and do 37 next and then 39 last. So number 37, exactly two lines of symmetry can't be done. It's not possible. Think about it. If a triangle like this has exactly one line of symmetry, and if an equilateral triangle has three lines of symmetry, so I just accidentally answered number 39, by the way. Number 39 says three lines of symmetry. That'd be an equilateral triangle, okay? But there's no triangle that you can draw that has exactly two lines of symmetry. You can draw a triangle like this, an isosceles, that has exactly one line of symmetry, or you can draw an equilateral triangle that has exactly 3 lines of symmetry, but you cannot draw a triangle that has exactly 2 lines of symmetry, okay? It is not possible. All right, numbers 40 through 43. Match the triangle with its name. Oh, I'm on the wrong page. Hold on one second. Triangle ABC is isosceles, and in all these triangles, AC is congruent to BC. So I'm going to go ahead and mark, put a slash here and a slash here, AC, BC. Here's AC and BC. Here's AC and BC, and here's AC, and here's BC. There. Okay. Solve for x, and then decide whether the triangle is equilateral. Let's quickly solve for x. This side here is congruent to this side here, so we can definitely state that 6 equals 2x plus 2, right? Because they're equal, they have the same length. So bring the 2 over and make it a negative 2. You're left with 4 equals 2x. Divide both sides by 2. And 2 equals x. So, yeehaw, that was pretty simple. Now let's see what the length of each side is. If I put it, excuse me, sorry. If I put a 2 in for x here, 2 times 2 is 4 plus 2 is 6. And if I put a 2 in here, 2 plus 1 is 3. So, are all 3 sides congruent? No, we have a 6 and a 6 and a 3. So, for this problem here, I would say x equals 2. And it is not an equilateral triangle. Okay, let's go ahead and take a look at number 41. This side here is congruent to this side here, so I can take 2x plus 6 and set it equal to 12. Bring the 6 over and make it a negative 6, so 2x equals 6. Divide both sides by 2, x equals 3. All right, now put a 3 in here, you'll get 12. We have a 12 here. Put a 3 in for x. 4 times 3 is 12. So look at that. All 3 sides have a length of 12, 12, and 12. So for this problem here, we would say x equals 3. And yes, it is an equilateral triangle. Okay? Number 42. This side here is congruent to this side here. So I would say 2x minus 1 equals x plus 1. And let's bring this negative 1 over and make it a positive 1. Okay. Let's bring this positive x over and make it a negative x. Let's see what we're left with here. 2x minus 1x would be x, or 1x if you want to put the 1 there, that's fine. And then 1 plus 1 would be 2, so x equals 2. Now, let's put a 2 in for x here. 2 times 2 is 4. 4 minus 1 is 3. Let's put a 2 here. 2 plus 1 is 3. Let's put a 2 here. 4 times 2 is 8. Minus 2 is 6. So no, we do not have an equilateral triangle. We have 3 sides. Their measurements are 3, 3, and 6. So we do not have an equilateral triangle. So we would state that x equals 2. And no, we do not have an equilateral triangle. Okay, now over here at number 43, this side here is congruent to this side here. So I would state that 2x equals 4x minus 6. And let's see, bring the 4x over and make it a negative 4x. So 2 minus 4 is a negative 2x. Bring down your negative 6. Divide both sides by a negative 2. Don't forget that a negative divided by a negative is a positive, so x equals 3. Okay. Well, let's put a 3 here. 2 times 3 is 6. We'll put a 3 here. 3 plus 3 is 6. We'll put a 3 here. 4 times 3 is 12, and 12 minus 6 is 6. So notice that all 3 sides do equal 6. So yes, we do have an equilateral triangle. Okay, so the answer to number 43 would be x equals 3. And yes, we have an equilateral triangle. Okay, and now numbers 44 through 47. All right, 44 through 47. Here we go. Okay, let's make this a little bigger here if we can. In fact, maybe I'll put this on the next page over to give us some more room. And here we go. All right, number 44. Find a location of S so that PQR is congruent is congruent to PQS. So here's PQR right here. PQR in red, okay, students. And then they want us to find, to draw a triangle PQS so that it's congruent to this triangle here. Well, here's P and here's Q. Where am I going to put S at so that I would have a congruent triangle? Well, how about right here? I mean, think about it. If this is triangle PQR right here, then let's call this S. Then triangle PQS would definitely be congruent to this triangle here, because if you look, this triangle here has a length of 2 going across, and this triangle does too, and then both sides go over 1, up 2, over 1, up 2, and this triangle here goes over 1 and down 2, and over 1 and down 2. Okay, so S would have to go right here, and that point would be 1, comma, negative 1. Okay, so where would S have to go so that triangle PQS is congruent to triangle PQR? S would have to go right here. Right here, okay? All right, number 45. Is PQR an isosceles triangle? Well, let's see. Let's take a look at PQR. I believe it is. Look, this side here has to be the same length as this side here. How do I know that? Because look, this side starts here and it goes over 1 and up 2. And this side here starts at Q and goes over 1 and up 2. So this side here is congruent to this side here. So yes, I definitely have a isosceles triangle, okay? Now, this next problem is interesting. Find 2 locations of V so that TUV is congruent to our triangle, okay? 2 locations for V. Well, here's TU. Well, it looks like to me if I put V right here, that would give me a triangle congruent to this triangle here. If I put V right here, which would be over 3 and up 5, so 3 comma 5, and I could also put V here, because this triangle right here would definitely be congruent to this triangle over here, and so the point of V right here would be over 3 and up 1, over 3 and up 1. So there's the 2 points that V could be. V could be 3 comma 5, or V could be 3 comma 1, okay? 3 comma 5 or 3 comma 1. All right, and lastly, we're going to use the distance formula to find the perimeter of PQR. Now that sounds like a really long problem, and it's actually a very short problem. Let me show you why. First of all, we already know the length of this side here is 2. 1 space, 2 spaces. So this side here has a length of 2. Now once I find the length of this side here, don't forget that the length of this side here would be the same as this length over here. They're the same length. So all I have to do is find the length of one side, and then I can very easily find the length of this side over here. Okay, so here we go. This ordered pair for R is 1, 3. Okay, 1, 3. And this point here for Q is over 2 and up 1. So we have to use the distance formula to find the distance between 1, 3 and 2, 1. So 1, 3, 2, 1. Distance formula, x minus x, quantity squared, plus y minus y, quantity squared. This is your x, this is your y, this is your x, this is your y. So 1 minus 2, so we have 1 minus 2 quantity squared plus y minus y, so 3 minus 1, quantity squared, and then 1 minus 2 would be negative 1 squared, and not sure why I put a y here, it'd be a 1, and then 3 minus 1 would be 2 squared. So we end up with negative 1 squared is 1, 2 times 2 is 4, so the square root of 5. Okay, so let's go back over here. The length of this segment right here is the square root of 5. So that tells us then that the length of this side over here would also be square root of 5. So what I have for the perimeter is this. And hopefully from Algebra 2 you remember how to add these square roots together, okay? So what you would have, hold on one second, what you would have is this. You would have one side that's square root of 5, one side that's square root of 5, and the other side that's 2. And so when you go to add these together, you add these two together here. They're very similar to having like terms. So square root of 5 plus square root of 5, there's a 1 here and a 1 here. So 1 square root of 5 plus 1 square root of 5 would be 2 square root of 5, and then bring down your plus 2. Okay, now if you type that whole thing into your calculator and had a decimal answer, I'm okay with that. Just know how to do it this way too, in case on a test or a quiz I asked you for a radical answer, not a decimal answer, okay? Alright, I hope this homework help video has been help to you. If you have any questions, don't hesitate to call or email.